Hi, I'm Kenny Lee, and today we're going to talk about solving problems about distance and acceleration. So if something's accelerating, then it's either speeding up, slowing down, or turning. Well, if it's speeding up, that means for each second it's going to go further and further and further. So with this equation, this is how far it would go normally if it's just traveling at that constant speed. Just take the velocity times the time. But this additional term is the acceleration term. This is how much more it will go if it's speeding up, or if the acceleration is negative, then it's how much less it will go because it's slowing down. And this is just an alternate form of the same exact equation, just with x's instead of d's, and that's the original position of the object. But we're going to mostly use this one in my video today. So, starting off with this, by the way, acceleration is meters per second squared. Think about it as meters per second per second. Think about it like this, and it makes more sense. It slows down or speeds up so many meters per second every second of acceleration. But we have to write it that way. Let's take a look at our first question. So we have a ball rolling at 5 meters per second when it starts down a ramp. So it's going along, then starts down a ramp. Its acceleration down the ramp is 3 meters per second squared. How far would it roll in 4 seconds? So if I was to do the whole guess method, it's rolling at that amount. So that's my original velocity. It's 5 meters per second. Starts down a ramp. The acceleration down the ramp is 3 meters per second squared. I can tell by the unit what that is. So that's my acceleration of 3 meters per second squared. And we've got a time of 4 seconds. And I want to figure out how far did it go, its distance. So I want to start off with the equation. D equals V0t plus 1/2 AT squared. And then we'll just plug in the numbers here. V0 is 5, time is 4 seconds, plus 1/2, acceleration is 3, times 4 squared. It's only the 4 that's squared. And now we just simply work out the math as we go through. 16, 8, 4. And so we should get a distance of 44 meters is how far that ball would have traveled during that time. Now let's take a look at another one. Let's take where we have to solve for maybe something different. So on this one, a ball is dropped from a height. We've got an acceleration, and we want to know how long will it take to hit the ground. Okay, so for this one, we have a distance of 6 meters. We have an acceleration of 9.8 meters per second squared. And we're looking for a time. If we look at our equation, equals V0t plus 1/2 AT squared. We're missing something. We're looking for t, that's no problem. D, yes. A, yes. But we don't know original velocity. But the problem states that it's dropped. If you drop something, that means the original velocity was 0. So that's another way we can hide a number in a statement. So if original velocity is 0, anything times 0 is 0, so that term cancels out. And we just are left with 6 equals 1/2. Acceleration is 9.8. And then we've got to find time. 4.9 t squared. So divide 6 by 4.9, and we get 1.2245. We get a bunch of numbers. But that is equal to t squared. We don't want t squared, we want t. So we're going to take the square root of that number. And we get that the time it takes for it to fall that distance to be 1.1, let's say we round off, 1 seconds. So 1.11 seconds to hit the ground. Okay, well those are kind of single equation problems. Let's see if we've got to find something else or something more than just one thing. We're now getting to the point where you should know several equations by now. And so let's see if we can solve for a couple of different things. So we got a car rolling down a ramp. Okay, the ramp, that's a distance of 30 meters in a time of 3 seconds. If the original acceleration is 4, so VO is 4 meters per second, we want to actually find two things. We want to find the acceleration and the final velocity. Well, that brings up a good question. So if we look at this, we've got two things that we can do. We're looking for final velocity. And so one equation that we know with final velocity in it is A equals VF minus VO over T. Problem is we don't know the acceleration or the final velocity, so we're kind of stuck with that one. So we need to figure out one of those two numbers to actually answer that one. So let's go to this one. D equals V0T plus 1/2 AT squared. Let's see what we've got here. We've got a distance, 30. Original velocity is 4. And we know a time is 3 seconds. Plus 1/2. We don't know A, but again, time is 3 seconds, and that's squared. So let's see what we can do. 3 squared is 9. Half of that's 4.5A. Move that over. So we get 18 equals 4.5A. We're going to solve for that. So 18 divided by 4.5 gives me 4. So 4 meters per second squared, or 4 meters per second is A. Now that we know that number, we can put it in there. And that means we only have one unknown in that problem. So that means we can solve it. So 4 VF we don't know. V0 is 4 seconds, or 4 meters per second. And time is 3. So that's going to be 12 equals VF minus 4. Add 4 to both sides. We get 16 meters per second is our final velocity for that object. So now we can actually do two calculations from one set of problem. All right, on this one, we've got a bike going from 10 meters per second to 35 meters per second in 2.5 seconds. We want to know its acceleration and how far did it travel. Okay, well, that seems very similar to the last one, except now we're solving for a couple other things, but we still got to find acceleration. But this time we're going to find distance as well. So let's see what we got to work with. Our original velocity is 10 meters per second, because it went from this to that. Our final velocity is 35 meters per second. If our time is 2.5 seconds. And we're looking for acceleration, and we're looking for the distance that it traveled. All right, well, we've got VF, VO, and T, so it makes sense that we start off with this one. A equals VF minus VO over T. VF is 35, VO is 10, and we got 2.5 seconds. So 25 divided by 2.5 gives us an acceleration of 10 meters per second squared. Now we're going to figure out distance traveled. Well, it is accelerating, so because it's accelerating, we can't just use V equals D over T. We need to actually use the distance while accelerating formula. So V0T plus 1/2 AT squared Distance is what we're looking for. Original velocity is 10. That's why it's handy to make that list. Time is 2.5 seconds plus 1/2. Acceleration is 10 times 2.5 seconds squared. So we just work through the math again. So it's going to be 25 plus 2.5 squared is, well, 6.25. Then we're going to multiply. Let's put that in screen. Multiply by 10 and then divide by 2 gives us 31.25. And we're simply going to add those together now. So the distance is 56.25 meters that object would have traveled. Now, if our acceleration happened to be negative, it would have lost that amount, so it wouldn't have gone past it, and our answer would have been negative. We can get a negative displacement. That just means it's behind where it started off from. Okay? Thank you very much, and join me later on for another video about physics. Goodbye.